Hi guys, my name is Melissa, and in today's video we're going to be talking about mixed numbers. So in the last video we talked about fractions and we dealt with how to convert fractions into whole numbers, how to add fractions, and we also compared different fractions by multiplying and dividing and learning about equivalent fractions. And so in today's video, we're also going to continue learning about fractions, but then we're going to learn about something called mixed numbers.
We're gonna go over the basics of fractions, and so I think we might not go over too much detail for fraction basics because we kind of assume that you guys remember, but I'm pretty sure that for some of you guys it still might be a little confusing. And if we have a really sturdy and solid base for fractions, later on it becomes really easy to add, multiply, divide, and all that. And so we're just gonna do a quick review of fractions. And so for fraction, it looks like this. So a, the number at the top, is called numerator, and the number at the bottom is called denominator. And so a fraction is basically when we divide something by something. And so A is the number that's being divided and B is the number that is dividing. So for example, if we're going to divide 42 by 8, A is 42 and B is going to be 8. And also, we're going to go over concepts of where we have to compare two fractions. And so if we have the same, for example, if we have A, C, and B is the denominator. So this is a scenario where the denominator is the same. So it's same denominator. But then the numerator is different. And in this case, A is greater than C. Then that means that this fraction is bigger. So when the denominator is the same, the fraction with the larger numerator, so the larger top number, is going to be larger. And that is because we're dividing a larger amount by the same amount. So for example, let's think of it as this. So since the numerator, or the number at the top, is the number that's being divided, let's say we have 20 apples and 10 apples. And B, or the denominator, is the number that is dividing. So we're dividing by B. We're dividing by the denominator. So let's say we're dividing by 2. So we're dividing by 2 because let's say we have 20 candies and 10 candies. And we want to give 2 candies per person. Then since we are dividing by 2, we know that we can give 10 people candies because we're giving 2 candies per person, and so we can give candies to 10 people. But on the other hand, we can only give candies to 5 people because we're dividing by 2. And so this is smaller. So basically for the results, when the numerator is bigger and the denominator is the same, then the fraction with the larger numerator is greater. But what happens if it's the opposite? What happens when the numerator, so the number in the top, is the same, but the denominator is different? Well, let's say that B is greater than D. Now in this case, the fraction with the smaller denominator is going to be larger. So d is the smaller denominator, so the fraction itself, a over d, is going to be larger. So it's the opposite with the example above. When the numerator is different and the denominator is the same, larger numerator is larger. But when the denominator is different and numerator is the same, the smaller denominator is larger. And so again, let's think of it using the candy example. So we have 20 candies, but since the numerator or the number we're dividing is the same, let's say we both have 20 candies. But then I want to give it to 5 people, and I want to give it to one person. I want to give it to 2 people. And so this is the number that we're dividing by, so these are the denominators. 20 divided by 5 is going to be 4. So each person is going to receive 4 candies each. But when you're only giving it to 2 people, each person is going to receive 10 candies each. So when the denominator is smaller, you divide by less, so the result becomes larger. We have that, and we're also going to do a basic review for addition as well, and subtraction. And so when we have the same denominator, let's say we have AC, and the denominator is both D. Then we have the same denominator. We have the same denominator, D. Then since the denominators are the same, the result of A over D plus C over D is going to be A plus C over D. Now it's the same for subtraction. If the denominator is the same, it's just going to be the numerator that changes, and the denominator is going to be that common denominator. But of course, there are times where the denominator is different, both for addition and subtraction. Then we have to find a common denominator. Usually we multiply those two, like DC. And then since we had to multiply C to this to get DC, we also multiply C to the numerator. Also, same thing, we had to multiply D here, so we also multiplied D there. Same thing for subtraction. Same thing for subtraction. It's going to be AC minus BD. So yeah, those are basically what we need to keep in mind when we do fractions. And so today we're going to learn about fractions and adding them. And we're also going to talk a little bit about using number lines to represent fractions. And so let's get right into it.
So before we go into mixed numbers, we want to talk about improper fractions and mixed numbers. So improper fractions are in the form of A over B, and so it's going to be like 27 over 6. So the numerator is bigger than the denominator usually for improper fractions. Now as for mixed numbers, we have a whole number and then we have our fraction. And our fraction is usually like where the denominator is larger. So the fraction is not yet a whole number. It's not greater than 1, but we have a whole number in front. So what the mixed number tells us, so as the name states, it's a mixed number. It's a mix of a whole number plus a fraction. And so what the mixed number tells us is that it has however many number of whole numbers it has. So I know that sounds confusing, so I'll just write down an example. So for example, if we have 2 and 3 over 4, this indicates that it has 2 wholes. And we know that one whole is 4 over 4 because 4 over 4 is 1. So that means we have 2 of 4 over 4, and we have a 3 over 4. And so that is going to translate to 8 over 4 plus 3 over 4, which is going to be 11 over 4. And so an easy way to convert a mixed number into an improper fraction, because sometimes it's easier to work with improper fractions when we add or subtract, is you multiply. So now that you've understood how to convert, what you do is you leave the denominator. So you leave the denominator, and then you multiply the whole number in the denominator. So that's going to be 2 times 4, which is 8. And then you add the original numerator, and so that's going to give you your improper fraction. And so now then what we should also learn about vice versa and what we should do when we convert from improper fractions to mixed numbers. So for example, if we have an improper fraction like 27 over 6, you first want to find out you first want to figure out a multiple of the denominator that is closest to the numerator but is still smaller than the numerator. So for example, a multiple of 6 that is closest to 27 and is smaller than 27 is going to be 24. So 6 times 4 is 24. And that's going to be the smallest and closest to 27. Then we know that we still have 3 over 6 missing, because 27 over 6 minus 24 over 6 is going to be 3 over 6. And so that is going to be, so this combination gives us 27 over 6. But then we know that 24 over 6 is 4. So that is going to be our whole number. And then we simplify this fraction into 1/2, and that's going to be the fraction portion of our mixed number. And so, yeah, if we try the trick to convert mixed number into improper fraction, leave the denominator, multiply, and add. So it's going to be 9 over 2. And so some of you guys might wonder, oh, 9 over 2 is not 27 over 6, but that is due to simplification. We multiplied by 3 for the denominator, also multiplied by 3 for the numerator, so those were equivalent expressions. And so that is how we change from improper fractions to mixed numbers, and from mixed numbers to improper fractions. And so we can write the result of division as a fraction or a mixed number. And so we'll see what this means by looking at an example problem. So it says, Ms. Q pours 64 ounces of lemonade into 5 glasses so that each glass holds an equal amount. How many ounces of lemonade are in each glass? And so she pours 64 into 5 glasses, so we're basically dividing 64 by 5. And 64 over 5 can be written as 60 over 5 plus 4 over 5. And 60 over 5 can be simplified into a whole number of 12. And so it can be written as 12 plus 4 over 5, which will be 12 4/5. And that is what we call a mixed number. And we call it a mixed number because it's a mix of a whole number and a fraction. Now we're going to go over some practice problems. And so it says, a 15-ounce bag of potato chips contains 6 servings. How many ounces of chips are in each serving? So here we're dividing 15 by 6. So writing this in fraction, it's going to be 15 over 6. And so that is basically going to be 12 over 6 plus 3 over 6. And 12 over 6 is 2, and 3 over 6 is 1/2. So we can write this as 2 plus 1/2, or 2 1/2. So it's going to be 2 1/2 ounce. And then for problem 56, it says, what is the side length in inches of a square with the perimeter of 39 inches? So since it's a square, all 4 sides are going to be equal. And so for each side, the perimeter is going to be 39 divided by 4. So it's going to be 39 over 4. And we know that this is a combination of 36 over 4 plus 3 over 4. And 36 over 4 is 9. So this is 9 plus 3 over 4, or 9 3/4. So each side is going to be 9 3/4 inch. And the next problem, Grog cuts a 22-inch rope into 3 pieces of equal length. So we're doing 22 divided by 3 to find out how many inches long each piece is. And 22 divided by 3 can be written as 22 over 3. And so that can be written as 21 over 3 plus 1 over 3. So that's going to be 7 plus 1 over 3. So that's going to be 7 1/3. So each rope is going to be 7 1/3 inch long. Then we have problem 58. So it says, 4 identical bags of BC Puff cereal weigh a total of 21 ounces. And so to calculate how many ounces each bag weighs, we're going to divide 21 by 4. And so it's going to be 21 divided by 4, so 21 over 4. And that's going to be 20 over 4 plus 1 over 4, which is 5 plus 1 over 4. So 5 1/4. So each bag is going to weigh 5 1/4 ounce. Now for problem 59, Brenda makes some candles using 28 ounces of wax. She uses half the wax to make 2 large candies, and she uses the rest to make 4 identical small candles. How many ounces of wax are there in each small candle? So she makes some using 28 ounces, and she uses half the wax to make 2 large candles. So first, she uses half of 28, so she uses 14 ounces to make 2 large candles. Then she has 14 ounces left to make 4 identical small candles. But we want to know how many ounces of wax there are in each small candle. So we're only going to be concerned with 14 divided by 4, or 14 over 4. And that can be the same thing as 12 over 4 plus 2 over 4. And so that's going to be 3 plus 1/2. So in each small candle, there's going to be 3 1/2 ounce of wax. Now we're going to move on to the next page. And so it says, write 57 over 9 as a mixed number in simplest form. So we can convert any fraction greater than 1 into a mixed number. And so, based on 57, we're going to look for a multiple of 9 that is closest to but still less than 57. So multiples can be 18, 27, 36, 45, and 54. And so 54 is going to be the closest multiple of 9 that is less than 57. And so if we have 57 over 9, then we still need to add 3 over 9. And 54 over 9 is going to be 6, and 3 over 9 is 1/3. So we can write 57 over 9 as 6 1/3. Now we're going to practice that using some practice problems. And so multiples of 10 that are closest to 53 but still less than 53 is going to be 50. So we're going to write this as 50 over 10 plus 3 over 10. So we can write this as 5 plus 3 over 10. So that would be 5 3/10. For 61, a multiple of 9 that is closest to but still less than 70 is going to be 63. So we're going to do 63 over 9 plus 7 over 9. And so that can be written as 7 plus 7 over 9. So that's going to be 7 7/9. Then we have problem 62. So a multiple of 4 that is less than 35 but closest to 35 is going to be 32 over 4. It's going to be 32. So we're going to write 32 over 4 plus 3 over 4. Since 3 plus 32 is 35. And so that's going to translate to 8 plus 3 over 4. So we're going to write 8 3/4. Now again, a multiple of 8 closest to 34 but still less than 34 is going to be 32. So we're going to write 32 over 8 plus 2 over 8. And so that can be written as 4 plus 1 over 4. So that's going to be 4 1/4. Now for problem 64, a multiple of 6 that is closest to 92 but still less than 92 is going to be 15. Well, not 15, so it's going to be 90. Since 90 is a multiple of 6, so we're going to do 90 over 6 plus 2 over 6. And 90 over 6 is basically 15 because 6 times 15 is 90. And so that's going to be 15 plus 2 over 6, which is 15 plus 1 over 3. So we can write 92 over 6 as 15 1/3 as a mixed number. And so for 68 over 12, a multiple of 12 that is less than 68 but still closest to 68 is going to be 60. So we're going to write 60 over 12 plus 8 over 12. And 60 over 12 is 5. So we write this as 5 plus 8 over 12. And 8 over 12 can be simplified into 5 plus 2 over 3. So we can write this as a mixed fraction 5 2/3. And then we're going to look at 137 over 5. So a multiple of 5 that is closest to 137 but still less than 137 is going to be 135. And again, using the divisibility test, it ends with the 5, so we automatically know that it's divisible by 5. Then we have 135 over 5 plus 2 over 5. And 135 over 5 is going to be 27. So this is going to be 27 plus 2 over 5, which is just 27 2/5 as a mixed number. And then we have 119 over 14. And so since we know that 8 equals 112 over 14, we're going to do 112 over 14 plus 7 over 14. And that is going to be 8 plus 1 over 2. So that's going to be 8 1/2. Now we're going to answer each question below, and it might be useful to rewrite the fraction to mixed numbers. And so it says, how many whole numbers are between 39 over 7 and 44 over 3? And so 39 over 7, if we want to write it into mixed fraction, we can write that as 35 over 7 plus 4 over 7, which is 5 plus 4 over 7. So that's going to be 5 4/7. And for 44 over 3, we can write that as 42 over 3 plus 2 over 3, and that is going to be 14 plus 2 over 3, which is 14 2/3. And so comparing 5 and 4/7 to 14 and 2/3, the whole numbers in between are going to be 6, 7, 8, 9, 10, 11, 12, 13, and 14. And so that's going to be 9 different whole numbers. Then it says circle the fraction below that is closest to 10. So 79 over 5 is close to 79 over 5 can be written as 75 over 5 plus 4 over 5. And so that is going to be 15 and 4 over 5. That's going to be 15 and 4 over 5. 17 over 11 is going to be 1 and 6 over 11. And for 111 over 8, we can write that as 104 over 8 plus 7 over 8. So that's going to be 13 and 7 over 8. And 51 over 4 can be written as 46 over 4. 48 over 4, sorry. 48 over 4 plus 3 over 4. So that can be written as 12 and 3/4. And so the number that is closest to 10 is going to be 12 3/4. So that's going to be 51/4. Now it says write the 4 fractions below in order from least to greatest. Now 59/9 is basically 54/9 plus 5/9. So that's going to be 6 5/9. 27/5 can be written as 25/5 plus 2/5. So that's going to be 5 2/5. 45/11 is going to be 44/11 plus 1/11. So it's going to be 4 1/11. And 31/8 is going to be 24/8 plus 7/8. So that can be written as 3 7/8. And so the smallest, just by looking at the whole number of the mixed number, the smallest is going to be 3, then 4, 5, 6. So in order from least to greatest, it's going to be 31/8, 45/11, 27/5, and 59/9, with 59/9 being the greatest. And so we can write that over here. And then it says, between which two consecutive whole numbers is 50/6 plus 65/7? So 50/6 can be written as 48/6 plus 2/6. That's going to be 8 plus 1/3. So 8 1/3. And 65/7 can be written as 63/7 plus 2/7. So that's going to be 9 plus 2/7. So that would be 9 2/7. And 9 plus 8 is going to give us 17. And 1/3 plus 2/7 is going to be greater than 17, but it's going to be less than 18. So it's going to be between the whole number 17 and 18. Now problem 72 says place inequality signs in the circle to compare the expressions below. So we have 33/4 plus 23/7. So 33/4 can be written as 32/4 plus 1/4. So that's going to be 8 1/4. 23/7 can be written as 21/7 plus 2/7. So that's going to be 3 2/7. So just by looking at the whole number, it's going to be around 11. Now 15/2, well, over a bit greater than 11, and 15/2 can be written as 14/2 plus 1/2, so it's going to be 7 1/2. 33/16 can be written as 32/16 plus 1/16, so it's going to be 2 1/16. And just by looking at the whole number, it's going to be a little over 9. And so 11 is greater than 9, and so this expression is going to be bigger. The expression on the left is going to be bigger. Now we're on the last page, and so we can write any mixed number as a fraction. And so we're doing it in reverse. So it says write 4 and 2/5 as a fraction in simplest form. Now to do this, we're going to basically multiply the denominator and the whole number, because what the whole number is saying is if the denominator is 5, then 1 is going to be 5/5, right? Then we have 4 1, so that's going to be 20/5. And we can write that by multiplying the whole number and the denominator and then placing that over the denominator. So it's going to be 5 times 4/5, which is going to be 20/5. And then we add the 2. So that's going to be 22/5 in simplest form. Now writing 7 2/3 in simplest form into a fraction, we're going to multiply. So it's going to be 21/3 plus 2/3, and that's going to be 23/3. Now for problem 6, we skipped 73, I'm sorry. So we're going to multiply and add. That gives us 11/2. For 75, again, multiply and add, and that is going to give us 83/7. Now for problem 76, again we multiply and add, and so that's going to give us 44/10, and we can simplify it by dividing by 2, so we're going to have 22/5. Then again multiply, so 30/5, and then add. That gives us 34/5, and we can't simplify this any further. Now our final question is multiply 9 times 9, so 81/9 plus 4/9, and that's going to give us 85/9. And that was the end of our lesson today. And so in today's lesson, we learned about fractions, especially mixed numbers, and we learned how to get from an improper fraction. So an improper fraction is where the fraction itself is greater than 1, so the numerator is greater than the denominator. And so we learned how to switch from an improper fraction to a mixed number, and also vice versa, where we go from a mixed number into an improper fraction. And so I hope you guys had a fun time in class today, and I'll see you guys in the next video.